Okay, so let's get started. Okay, so does everybody have a machine, or I guess at least shared access to a machine? Okay, so we're now completely maxed out. So we have 29 machines and 29 people signed up for the class. And so if you're just auditing or you're just sitting in today, if you could be a good sport and give your machine or share your machine with folks who are actually registered. So we'll see what happens the next week or two. It could be that people drop or whatever, but right now we are really at capacity. Okay. Okay, so the folks that signed up last time, who came and gave me their email addresses, I sent you the information to do the override, etc. So you should have been able to register for the course, but it's not clear whether Compass is able to pick that up immediately. So sometimes there's a lag on Compass. And so that means you can't download the files. And so I've posted the files for the first module for you at this address. And so you can go here if you don't have access to Compass, and you can just download the files for the first module. And so this is not navigable. You can't just go to my webpage and navigate here. You have to type this whole thing into the address bar. And so it's ferguson.matc.illinois.edu/download/MSE498AF_module1.zip. And so you should be able to grab the zip archive of all the files that you need from there. Okay, so I'm going to pass around the sign-up sheet, so if you could just sign your name and pass that along. Thank you. And then we're going to get started. So has everyone got this address that needs it? Anyone still waiting? Okay. All right, very good. Okay, so last time, what did we do? We sort of introduced the idea of computational materials science and engineering and integrated computational materials engineering. And then we started talking about, why might you want to do these things? How might you do these things? Why do we do these things in practice? So for academia, for industry, for public policy, all that sort of stuff. So computational materials science and engineering is becoming more and more important. And then we said if you actually want to do any sort of serious MSE, you probably have to be familiar with Linux and Bash, because 90% of scientific software is written for Linux and you interact with it using Bash. So Bash is the command line interface that comes with Linux and Macintosh. And you can get emulators on Windows. And so then we said, okay, if we're going to do that, then we need to start learning some basic Bash commands and getting familiar with Bash. And so we're setting the groundwork for actually using some software a little bit later in the course. Okay, so we went over some basic Bash commands, and like I said last time, I want you to think of this lecture as basically a library. So I don't want you to remember all these commands, I just want you to introduce them to you. And when you need them, you can go to this lecture and look them up. And then just getting familiar with sort of navigating around the Bash shell, making files, changing directories, stuff like that. And so today we're just going to go into a little bit more detail to provide you some more commands, so increase your Bash vocabulary. And so you don't necessarily need to, learn these commands and use them immediately. That's the purpose of the project that you're going to be assigned. And so you're actually going to implement some Bash code, write a little Bash script to download stock prices and print them in a nice way. Okay, and so where we finished up last time, so let me go back a couple of slides. Okay, so this is where we started. We had present working directory, ls, and cd. So that was the basic commands for sort of navigating around the shell. And so I encouraged you to pop a Bash shell on your computer and just practice sort of navigating. And then we said, okay, you can make files by the touch command. That makes a file appear. Make dir makes a directory appear. And so you have to make sure that you have right privileges in the directory you want to make these files or directories. And so on these machines, it's going to be your /home/username. So my username is ALS, so I would have right privileges in /home/ALS. You would replace ALS with whatever your username is. If you happen to be in a different directory, these systems are locked so that you can't just write anywhere. And so in that case, you won't be able to make files. So just make sure you're in your home directory when you want to be doing stuff like this. And then what you're going to do when you actually do the project is you're going to do touch file, and then you're going to open it in some text editor, you're going to write a Bash script, and then at some point you're going to want to execute that script. And so in order to make your file executable, you'll have to change the mode of the file to be executable. So 755, we said, gives you read, write, and execute privileges, and gives everyone else just read and execute privileges. And so that's the way you make your file executable. And so that's an important thing we learned. Okay, and then we did how you actually execute a file. We'll touch on that again, and did some stuff downloading things from the internet. And so you're actually going to implement this wget command to pull data down from Yahoo Finance in your project. Okay, then we did copying, moving, and removing. And we said, be very, very careful with this command. Once you delete it, it's gone forever. It's not like trash can. So rm, delete a file, rm-r, recursively delete a directory and everything in it. Those are gone for good. You're never getting them back. Just be very careful with the rm command. Okay, so let's just run through a few more commands. So we're going to have a few more slides, just expanding your vocabulary of bash commands. And then we're going to start introducing some scripts. And so if you want to navigate to Compass, or you want to navigate to that address that I had up here and download those files, you'll see that I've uploaded for you a bunch of bash scripts. And so we're going to discuss them momentarily. And they're going to provide you some sort of bash in action examples. And they're also going to form the basis of your project. And so you'll be able to use these scripts and adapt them and sort of stick them together in different ways to actually do your project. Okay, so let's talk about a few more bash commands. So if you arrive at a terminal and you log in, then you type who am I, it shows your login username, so probably you should know that, but if you forget, I guess that's a good way of finding it. And then if you type who, it shows everyone who's currently logged in. And so if you're on some sort of shared computing system, you can see who's logged in and who's using the files, etc. Okay, so then we talked about how you make a file, so how do you actually view a file? Well, there are a couple of ways. So these commands are pretty much interchangeable. So cat is just shorthand for sort of concatenate, and actually people don't use it just to concatenate files, they use it to view files as well. So if you hit cat and then you have a file called readme.txt, it will cause that file to appear in your bash terminal. Similarly, less is an also way of showing the file contents. And then spacebar takes you down and B takes you back up. So that is actually the functionality when you type man and then the command name. Remember, we pulled up the manual for a particular command. It actually visualizes the manual using less. And so you can navigate in less using spacebar to take you down, B to take you up, and escape to take you out of less. So other ways to do it, you can look at the top of the file using head, the bottom of the file using tail, the bottom few lines of the file by modifying the tail command with -n. So I just want to see the final line, tail-n1 would show you the final line of the file. Maybe that's useful because you want to see whether your code executed and got to the end of where you expected. And you can actually follow a file using tail, doing tail-f, and then the file name. So if you have a quantum espresso program that's constantly writing data to an output file, you can use tail-f to actually follow the output in real time. And so you can see what's being dumped to that file as the program is dumping it. So again, don't memorize these, but they're here if you need them. A couple more. These are pretty simple. You'll sometimes be asked to do your project. You'll have a bunch of files associated with your project, and I'll ask you to put them in a zip archive and then upload the zip archive to Compass. So of course you can do that on your terminal through the GUI just by selecting all the files, right-clicking and hitting zip. Or you can do it through the command line interface. And so as we discussed, one of the goals of this course is to get familiar with the command line interface. So though it might take a couple, trial and error, maybe a little bit longer to do this, I would encourage you to do things through the command line interface just to get comfortable with it. So you can zip files like this. You just type zip, the name of your archive, maybe project1.zip, and then just a list of all the files you want to dump into that zip archive. And similarly, when I get it from you, download it from Compass, I'm going to unzip it doing the inverse. So very simple. If you're a Mac user, you might be familiar with this tar command, which stands for tape archive. So it's very similar to zip. It's just a different way of compressing files that Macintoshes like to do, and Linux actually also. And so you can create a tape archive in this way. And so you give the name of the archive. Typically this ends in TGZ, which stands for tape archive gzipped. And then you have all the files. And you actually need to supply some flags to tar to tell it what to do, which in this case is compress, verbosely, zip them, and I want to make a file. And if you want to unzip, you just do tape archive extract verbose zip file. Okay, and so you can look up the man page for tar if you want to see what those flags actually do, but those are the ones that you'll use in practice. So maybe you can just think about this as a unit, a way to make the archive and a way to sort of decompress the archive. Okay, so if you have any questions as we're going along, please stop me. So please just stick your hand up. Okay, so pretty elementary stuff. Okay, so maybe you're running your code, it's taking much, much longer than you expected, and so you're wondering whether it's hung, whether it's actually still running on your computer. And so what you can do is use this top command to show all the active processes on your computer. And so if you pop the terminal and you just type top, it will give you a list of all the stuff that's currently running. And so maybe you can see whether your molecular dynamics code is running at 100% and is still taking, just a long time to work, or maybe it's stalled out at 0% CPU and it tells you there might be a problem. You can also do some fancier things with the -O flag, which tells you to order things, in this case by CPU. So that will provide the stuff that's using the most CPU at the top, and then an ordered list. You can also order it by user, and so you can see the particular things that you are running, as opposed to what the system is running, or anyone else who's logged onto the computer might be running. So just a couple of useful things. Obviously, there are other flags, and so you can do man top, and that will show you all the possible listings. Okay, another couple of useful sort of ancillary commands is gret. And so gret is a utility to do a rapid search in a file. And so imagine you had this output file from Quantum Espresso, and it turns out that Quantum Espresso has the important lines prefixed by an exclamation point. And so your final energy will say exclamation point E final equals something. And so that's a nice sort of handle in order to use the gret tool to pull out all the lines in your file that start with an exclamation point. So it allows you to search the file very quickly. And so you would do gret, exclamation point, and then the output file from your code. And it would pull out all the lines starting with an exclamation point. So it's a nice sort of utility to do rapid file searching, rather than opening the file in a text editor and just scrolling through it until you find the answer. And another very nice one, if you lose a file, you can try and find it using the terminal. And so if you use Mac, I think it's like Spotlight, which is in the top right of your window, uses this utility basically. And so you do find the path that you want to search stuff in. So that would probably be your home directory, so /home/ALF in my case, /home/your username in your case. You tell find you want to search for stuff by name. So this is the -name flag. The string you want to look for, and then you tell it to print it to the screen if it finds it. So you might have lost some file, and this allows you to find the file. So give that guy a shot if you want to sort of explore how you can search for stuff in your home directory very quickly. And then always remember that there are three places to help. You can type the command, and sometimes you do --help, and it will give you sort of online help for the command. Or you can type man and then the command name, and that will pop up the manual page. Maybe the simplest thing to do is actually just use Google. And so you can just search, bash command and type it into Google. So Google's your buddy. Google's your buddy for this course in general, actually. You'll start using LAMMPS and you won't know what the heck's happening, and so you'll use Google to try and figure that out. So you can either go to the LAMMPS website, or you can just Google LAMMPS commands and see if there are forums to help you out. And so don't be scared to use Google. I use it all the time. I don't memorize these commands. Sometimes I forget one, and so I'll look it up on the web. Okay, and then so there are some bash sort of shortcuts, some special symbols. And so it turns out that this tilde symbol is a shortcut for your home directory. And so instead of doing cd/home/ALF, which would take me to my home directory, I would do cd space tilde, and that would take me to my home directory. So it's a shortcut to get home, which you're going to use all the time. A couple other shortcuts, and we talked about these before. The period stands for the current directory. And so if I do ls space period, that will give me a listing of all the files in the current directory. If I do ls space double period, that will give me a listing of all the files in the directory above me. And so that's the mother directory in which you're living. And so always sort of bear in mind as you're navigating around your directory hierarchy to think about things on levels. And so you go down into a directory, you can go one step down beyond that, you can pop back up, you can pop back up again. So always just sort of keep track in a mental model in your mind where you think you are. And if you get lost, you can always type pwd, and that will tell you your present working directory, give you your current coordinates. This is sometimes useful. It's a wildcard character. So for example, if you're looking, let me go back one slide. If you're trying to find a file, you might add some wildcard characters into the string that you're searching for. And so you don't remember completely the file name, but you kind of remember what it sort of looks like. And so you can use some wildcards to help you do that. This is an important character, the escape character. So I can never remember, is this a / or a backslash? It's a backslash, okay. I just have this mental block where I can never remember this. Okay, so backslash escapes the character. So if you want to make a directory called my directory with a space between my and directory, you have to tell bash that this is actually a space character, and not separating two different arguments. And so you put a backslash in there to escape the space and tell it, okay, I actually want to call this whole thing my directory. I would actually advise against putting any spaces in directory or file names. Typically you want to use an underscore instead. And so either I would call this my directory without a space or my underscore directory, just because it's a pain to have spaces because you always have to remember to escape stuff. So, just a tip, I would use underscores rather than spaces. Okay, and this final character, this vertical line, which I think you can find in the top left of your keyboard typically. So where is that guy? Okay, so the top right, just under the backspace key. If you press Shift backslash, you'll get this pipe character. And what this character does is it takes the output from one command and just pipes it to a second command. And so maybe I want to look at the contents of a file, so I'm going to use cat to pull up the contents of a file, and then I'm going to pipe it to a grep command. And so that's going to then search that output for a particular word, in this case, tungsten. So you can link as many commands as you like together using pipes. It just takes the output from one command and dumps it to the input of another. So that can be useful for sort of daisy chaining various commands rather than typing them all separately. Okay, so we're going to get some practice in using these things. I really just want you to expose you to what Bash can actually do, then we'll get some practice doing it. Okay, so last slide on vocabulary. A few more special symbols. This redirects the output of a command to a different place. And so if you type cat and then a file name, it will output that file to the screen. Imagine instead you wanted to dump that output to another file. In that case, you might use the redirect command. So you would do cat file name, then this redirect command, which is the greater than sign, and then a new file name. So for instance, cat oldfile.txt greater than newfile.txt. And it would take the output from the old file, dump it into the new file, and make that new file in your current working directory. And so this is going to overwrite anything that currently exists in newfile.txt. If instead you want to append to an existing file, so add stuff to the bottom of a file that's already there, you need to use double greater than sign. So very efficient. It's sort of a very nice, clean way of doing things, but you have to be careful that you don't overwrite stuff that you don't want to. So just take a little care there. So for example, you go home today, you had a wonderful class in MSE 498AF, and you want to write this to your diary. So you do echo, today was great, and then you're going to append this to mydiary.txt, for example. So nice toy example of how that works. Okay, so we talked about this before, so dereferencing a variable. If I had assigned the value of 4.2 to VAR, so perhaps that's the lattice constant for aluminum that I'm going to pass to a quantum espresso code at some point. If I want to figure out what value have I assigned to variable VAR, I would do echo $VAR, and that would show me what's been assigned to that variable. Okay, then just a quick word about quotes. And so if you enclose something in double quotes, Bash is smart and it expands anything that has a dollar sign. So if you wrote echo double quotes, today was great $VAR, and VAR would say 4.2, what it would print to the screen was today was great 4.2. If you enclosed it in single quotes, it would not expand out VAR. Instead, it would just print $VAR. So depending on what behavior you want, you need to use double quotes or single quotes. So 90% of the time I use double quotes because I do actually want to access whatever's in a variable. But just be aware that the single quotes do something a little bit different. Okay, and then the final thing is this sort of weird prime character. So that guy I think is in the top left. Yep, so under the tilde, this prime character tells Bash, okay, I'm going to write you a line I want you to execute, but I want you to do the stuff between the prime characters first. So we're going to see this in just a second, but this is a utility that does sort of simple addition and subtraction directly on the Bash line. And so you could do expr 1 plus 1, and that's going to evaluate 1 plus 1, give the answer 2. And you need to tell Bash that if you're echoing this to the screen, you want it to execute this first and then print the answer. And so those prime characters say, execute this chunk, it's going to compute the value 2, and then echo the value 2 to the screen. So you can give that a shot. So that's going to be useful for sort of when you want things to be executed in a different order from what you type them. And you're going to get some practice with it. Okay, so any questions on sort of the vocabulary stuff? Okay, so let's talk about some utilities. So I'm just going to give you an overview of some useful bash utilities, and then we're going to get into looking at the scripts together to actually see these in practice. Okay, so we've seen the sort of capabilities of bash, but bash actually comes prepackaged with a bunch of utilities that it can call. And so expr is one of them. And so it's like a little mini program that's sort of built into bash that can do integer arithmetic. And so this can be very nice if you want to write scripts to do stuff on the fly. And so if you want to increment a variable, so bash can execute a loop. And so I equals 1, then it goes through the loop. You want to increment I to be 2, 3, 4, 5, so you can make a nice for loop. You could use this little utility. So for example, we've already seen that you could echo expr 1 plus 1, and that would give you the value 2. You can also assign variables, and so var1 equals, and then the prime characters to tell bash you want to execute this first, 10 times 2. So a couple of notes here. Be careful you don't have spaces between your variables and the expr. There's no spaces either side of this equal sign. And here we recognize this guy as the wildcard character, and so we have to be a little bit careful when we call it with the expr to escape it first, to say, no, we're not doing a wildcard, we're actually doing a multiplication symbol. So you just have to remember that, unfortunately. You can also do division. You can echo things, and so we can echo variable 1, variable 2, and then the quotient of variable 1 and variable 2. So, just play with these things either now by typing them into your terminal or when you get some time later on today, just to get comfortable with doing these things. Okay, and so if you're at home and you want to log into the EWS terminal without, trudging through the snow, if it's sort of November time, you can actually log into them remotely via the command line. And so this is something called an SSH. It stands for a secure shell. And so we're using the bash shell, but it turns out if you want to tunnel remotely, you can make bash behave like a sort of remote tunnel, and it's called a secure shell. And this is a little program that comes embedded with bash. And so what you would do is you would sit at home, you would open up your laptop, and you would write SSH, your username, at the host name. So, for example, if I wanted to log into these Linux machines, I would do SSH ALS at, and then this is the host name for the Linux machines. And that would basically open up a tunnel to one of these Linux machines, actually one in a data center rather than one in this room. I would type in my password, and that would give me a bash terminal as if I were just sitting in front of a computer here today. And so it's like just accessing your bash terminal remotely. So this can be a very nice way of sort of saving you from walking to place to place. The flag that I use most often with SSH is -Y. You may or may not need to use this, but if you're doing any sort of visualization on the remote machine and you want the visualization to come back to your local machine, it needs to use something called X forwarding. And so this -Y flag allows those graphics to come back to your local machine. So that can be very, very slow if they're intensive graphics, but if they're sort of, just making some pretty pictures, some JPEGs, it's probably okay. And so you can use this flag. Okay, so that's how you open up a bash shell on a remote computer, but what about if you actually want to transfer files back and forward? And so you need to use a different utility called SCP, which stands for secure copy. And the syntax for this is secure copy your source file, which is on your local machine, and then you open up a tunnel to the remote machine, so ALS at remotelinux.ews.illinois.edu, tilde, and then the target where you want to send it, so maybe /home/ALS. And that would take the file on my local machine and copy it up to my home directory on my EWS server. And then you just invert the order if you want to copy something back. And so if you want to copy something from the remote machine, you just put this stuff first, and to your local machine, maybe you would do /desktop or something, and then that would copy the file back to your local desktop. So you're going to get some practice doing these things because you're going to want to upload and download files from your home computer to your remote space. Okay, and so if you're happy with secure copy, you can stop listening for this particular slide, but there's a fancier version to copy files back and forward called Secure File Transfer Protocol, so SFTP. And so it's just an alternative way of doing things, copying files back and forward. And so basically you type SFTP, your username, at your host name, so ALS at remotelinux.illinois.edu. Then it's going to open up a shell. And that shell is going to exist sort of in two places at once. It's going to exist on your local machine and on the remote machine. And so you need to do two things. You need to first of all navigate on your local machine where you want to be, so maybe the desktop, maybe your home directory. then you need to navigate on the remote machine where you want to be, and then you need to push files back and forward. And so the way you navigate on the remote machine is using the standard commands. And so ls, pwd, cd to move around. And the way you navigate on the local machine is to just prefix those commands with L, standing for local. And so you could do local ls, local present working directory, local change directory. And when you're happy you're in the correct directory on the local machine and the remote machine, then you just type get and put to put things back and forward. So get grabs a file from the remote place, pulls it down to your local space. Put grabs a file from your local space, puts up to the remote space. So I actually find this more convenient than SCP, but it's whatever you prefer, and then you can quit out of it. Okay, so maybe give that a go too at some point this evening, just to practice sort of moving files around. So relatively simple, but very powerful. Okay, and so we're starting to write a little bash script, and we don't want to go to the hassle of quitting out of the command line interface, opening the graphical desktop environment, finding our text editor, opening up the script, and then just adding a period that we missed. Wouldn't it be great if we could do everything sort of on the fly in our bash terminal? And so bash actually comes with two, actually there are more, but two common command line interface text editors, VI, or sometimes known as VIM, and Emacs. And so this seems like a huge pain if you come from sort of the GUI environment. Why would you want to edit text files in the bash terminal? It turns out it's just super efficient. And so if all you want to do is add a period or change a word or change a variable, it's much, much quicker to do it directly in the bash terminal and then re-execute your file rather than, going to the hassle of flipping over to GDE and that. And so it's very fashionable to argue over which is better. I prefer to use VI, so that's the one I'm going to present to you today, but if you're more comfortable with Emacs, go ahead and use that. They both do exactly the same thing. They're just bash text editors. Okay, and so VI has two modes. And so the right way to think about VI is you can be in one of two modes. You can be in navigation mode or sort of insert mode. And so navigation mode allows you to move your cursor all over the file, and then insert mode actually allows you to type and delete text. And so you have to be aware of which mode that you're in. So nav mode is the default mode and can always be accessed by hitting escape. And so when people are using VI, you'll see them frequently just hammering the escape key like a bunch of times to make sure they're in navigation mode and they're not going to overwrite their file. And then the way to get into insert mode is to hit the small letter I. And so that takes you into insert mode and you can just start typing. So let me provide you just the vocabulary for this. And so as you sort of pop a VI terminal, you can start to use these things. And we're going to actually we're going to do a sort of hands-on thing together using VI in just 1 second. But let me introduce to you how we actually use it. So you would do VI file name. It would open up the file, and you default start in nav mode. And so you use the arrow keys to sort of move around. There's some shortcuts to move around quickly. So GG takes you to the top of the file, caret takes you to the beginning of the line, dollar takes you to the end of the line. This allows you to go to a particular line, skip a word, skip backwards one word. So just some shortcuts. But basically, you can do everything with the arrow keys. It's just if you have very long files, you might need to use these shortcuts, and you can look them up here. Okay, you can copy things, and so this stands for yank, and so YY yanks the whole line, or similarly $Y yanks everything to the end of the line. You can copy a particular number of lines down, so Y5 would copy the 5 lines below your cursor. Then you could navigate somewhere and paste them. So you can do copy and paste, actually, using this text editor. When you're in nav mode, you can actually delete stuff without going into insert mode. And so you can delete a character using X. You can create a new line using O. And then you can enter insert mode, like I said, by hitting I, little I, which is the most common way to do things, to get from nav to insert. But there are actually fancier ways of getting from nav to insert. So imagine you wanted to enter insert mode and also jump to the beginning of the line. You would use capital I. Little a is insert mode to the right of the current character. Capital A is insert mode at the end of the line. So just various quick shortcuts to get into insert mode perhaps more efficiently. All you really need to remember is little I. That's good enough. You can also delete things in nav mode. So double D will delete the whole line. You can delete a particular number of words, a particular number of lines. And this is a valuable command, undo, and so you can hit U, you screw something up, you hit U, and it takes you backwards. So maybe you'll never need to use these, but you can also do find commands. So if you type / and then the string you're searching for, and then hit enter, VI will actually do a search of your file for you, so you can find a word that you're looking for or find a character that you're looking for. And this takes you backward search. You can go to the next match, or you can go to the nth match. So I very rarely use this, but this exists. So I'm just making you aware that this exists. Okay, so you've entered insert mode, you sort of typed all the stuff you want to type, you hit escape to get back into nav mode, and now you want to save your work. So how do you save your work? You save it by doing :W, and so that's the control save equivalent in VI. So that then saves the work that you've done on your file. I don't recommend you do this, but :W exclamation point allows you to oversave a read-only file, and so the file is probably read-only for a good reason, and so probably you don't want to oversave this. If it turns out that it's a file you've created and you know it should be write eligible, how might you change it to be writable to you? What command might you use? So change mode. So you would go into your bash terminal, you do chmod, and you change the mode of the file to be writable to you. This quits you out. It's going to warn you if you haven't saved your file. This quits you out without questioning you, so again, don't really use that one. This is a simultaneously write and quit, and this is a simultaneously write and quit exclamation point. It takes you out no matter whether it's going to throw you a warning or not. So bottom line is don't use exclamation points, but they exist if you need them. Okay, and then insert mode is super easy, and so you just type normally, whatever you type appears on the screen, and then the arrow keys work just as in nav mode, and so you can move around and type stuff. And so we're going to practice that in a second. And as we said, you hit escape to get back to nav mode. Okay, so before we do our example, let me introduce one final thing, which are these sort of hidden files. And so you may or may not know, but your computer contains a bunch of hidden files. They're sort of system files that users shouldn't really need to mess with too much. And so in order to hide them from the GUI, so all those poor people that can only use GUIs and don't know anything about the bash terminal can never see these files, but us as bash users, we can actually access them. And so one of the most important ones is one that lives in your home directory called, so you go to your home directory, so you do cd:/.bash_profile. And so it turns out that this is a file that's connected with your personal profile that stores all your sort of privileges and all of your shortcuts and all of the settings that automatically boot every time that you launch a terminal. There's another one called bash_rc, so the resource file, which is sort of less important. It's sort of connected with the bash profile. Bash profile actually calls it every time you load a terminal, but the bash profile is the most important one. So what we can do is actually make some modifications to our bash profile to make our lives a little bit easier. And so we're going to do that using VI. Okay, and so what we're going to do today together is that we're going to say, okay, I tend to type this command a lot. And so instead of typing ls, I want to actually modify the ls command to list all the files, even the hidden ones, and list them in long form. And so I type this so much that I don't want to continually be typing ls space -al. So let's make an alias. It would be much simpler for me if I could just hit LLS, and that would be a shortcut to execute this particular command here. And so let's modify my bash file to do this for me. And so I think you can modify either your bash resource or your bash profile. In this case, we're doing bash resource. And so how does that look? So let's do that together. So let's open up a terminal. So here's your terminal. Let's go to our home directory. So cd tilde is going to take us home. Excuse me. Here we go. So cd tilde is going to take you home. And so if you hit pwd, you're going to be in your home directory. So for you, it's going to read /home/username. Okay, so now we're going to edit our file. So first of all, let's do ls-al. And you should see all these hidden files up at the top there. So you can see the bash profile file right here. You will also see, I think on your Linux systems, the bash_rc file. And those are the ones that we're going to modify. Okay. Let me try and project these things simultaneously. Okay, so then let's type in vi /.bashrc. So it's going to pull up a vi editor for your resource file. Is everyone okay with that? Everyone seems to have an editor. They can see their file. Okay, so be very careful messing around with this file, so don't type anything too quickly. So ls-al. That's right. So dash is the modifier. Yeah, the minus sign. Got it? Okay. Okay, so I want you guys to edit your bash rc file by typing this command here. So vi.bash rc. So is everyone okay with that so far? Okay, if you got a problem, stick your hand up. Okay, so then let's navigate to the end of the file. So I'm actually going to edit a different file because I'm on a Macintosh. Oops, so vi. Okay, so this is my file right here. And so you can use the arrow keys to move up and down, like we said. So you can press the bottom arrow key, the down arrow, and hold it down to get to the end of the file, or you can type capital G, and that will take you all the way down to the end of the file. Okay, now we want to create a new line. And so the way you create a new line very efficiently is to press O, and so the lowercase letter O. So what's happened is two things. We've created a new line, and it's also jumped us into insert mode. And so now we can insert stuff. And so what we're going to insert is a special command. And so it's called alias. So alias space LLS equals ls-al close quotation marks. So just this line right here. So alias LLS equals, no spaces around the equal sign, be very careful about that. Open double quotations, ls-al close quotations. Everyone okay with that? Okay, so now we want to hit escape because we want to get back into nav mode. So we hit the escape key, so you see the insert disappears. So everyone's hit escape. If you're a real bash user, you'd be going like this to make sure you're in nav mode. And then you type colon lowercase w. And that will save your work. So you can see that this has been written, and it tells you that the file has been written and saved. And then you hit colon q return, and that will quit. Or you can do them simultaneously and do colon WQ, and that will simultaneously save the file and quit you out. Okay, so now what I want you to do is close your bash terminal and open up a new one. So why are we doing that? Because the bash profile and bash resource file are executed upon launching a new terminal. And so we're going to launch a new terminal, and that new terminal is going to now have that alias command. So let's launch our new terminal, and then let's try it. Let's go to our home directory. Let's do LLS. Terrific. So that just saves us a bunch of work because now we don't have to type ls-al every time. So did everyone make it through that? Anyone have any trouble?
Yeah,
it's just
writing
blank.
a new file.
Oh, okay. So you should definitely have one. So let's get out of here.
But yeah, let's kill them.
Yeah, you don't think of a bash RC file. Okay, that's a little strange. So let's just try and do this anyway. Yeah, so just make a new file. Yeah, so just go ahead and fill that in. Yeah, just do exactly this, although it will be a new file, but that's okay. So now you can just hit I to go into insert mode, and then type in the alias, yeah. So because you don't have a complete file, you don't need to go to the end or make a new line. You just need to type this directory. Okay, and then hit escape, and then go up to the top actually because you have a rogue G up there. So if you hit double D, so a little D twice, I'll delete that line. in colon WQ. Okay, great. And then close your terminal and open a new one. And then let's try type LLS. Okay, so it worked. So I don't know why you don't have a bash RC file, but now you do.
What's the best RC file?
It just saves your sort of profile information and your privileges and any shortcuts.
So it's there automatically, or
It should be there automatically, so I don't know why you don't have one, but now you do. And so now you have one that you can modify. So yeah, you're fine. Okay. Yep, looks good.
Okay. So the benefit of doing this was that we don't have to type it. We don't have to retype it, or
So you don't have to retype this all the time.
okay. So what this allows us to do is to go into the local directory without having to tell it to go to the local directory.
So this actually stands for list in long form.
Okay.
So you're listing stuff in long form.
Okay. So where have you seen this?
Yeah, so that's a good point. Actually, I'll discuss this right now. It's a nice question. Okay, so when you list stuff in long form, it actually gives you more information about the files. So if you just hit ls, it just gives you sort of a short form list. If you do your shortcut, which was ls-l, or actually I like to do al, because it also shows the hidden files, it gives you more information about them. So let's look at this one. So this is the desktop. Let's look along here. This tells you the privileges associated with it. It tells you it's a directory, D, and then the first three characters after the D tell me that I have read, write, and execute privileges. The next three characters tell me the privileges that everyone in my group has, which is none. And then the next three tell me the privileges that the rest of the world has, which is none. And so when you do change mode, these things will change. And so let me touch exec. So I'm going to make a file called exec. I'm going to do ls-al. You see this little file exec down here. And so you can see that I have read and write privileges. The rest of my group just has read privileges. And the rest of the world just has read privileges. Now let me change that, because maybe this is a bash script in which I actually want to run the program, and so I want it to be executable. And so let me do change mode 755 exec ls-al. And now we can see that exec has different privileges. It's not a directory. There's no D here. I have read, write, and execute. The rest of my group has read and execute, and the rest of the world has read and execute. And so if you've written a bash script and you can't seem to execute it, probably your privileges are wrong, and you need to do change mode. Okay, that was an example, so I'm going to delete this file. I'm pretty comfortable with the rm command. So remove exec, and it's gone. Okay. So any questions about modifying your bash resource? Yeah. Yeah, that was a good question. So I realized when I was looking through these slides this morning that I duplicated these. I probably shouldn't have done that. But no, it will not affect that. So when you call SFTP, you actually launch a brand new utility that doesn't really care about your bash profile, and all the commands in there remain the same. So probably what I should have done is not call this LLS. I should have called it something different. And so you can give it whatever alias you like if you don't like LLS. A good question. Okay, so let's proceed. Okay, so that was my bash resource file, and so you can see that I've added this thing to the end. Okay, so another modification you might want to make, and we're not going to go through this together, but you're very welcome to do this if you like, and this is one that I have in all my bash resource files, is to modify your path. And so your path is a special internal system variable that tells the system where it should look for things whenever you type a command. And so whenever you type the ls command or the change directory command, it actually goes and accesses a particular place in your system where those commands are stored. And the path tells the system where it should look. So now imagine you're making a new program and you want to execute this program very frequently, and you don't always want to type the fully qualified path name to this program. So maybe it's stored in /home/alf/my brand new super duper molecular dynamics code. So instead of typing that the whole time, type /home/alf/ slash my programs, my super duper molecular dynamics code slash execute, I might want to make that directory as part of my path. And the way you can do that is to add it to your path. And you can do that very simply by going into your bash resource file and saying navigation to the end, and then saying export, which means send to the system, so let the system know about this, that my new path is going to be my old path, colon, this extra stuff on the end. And so this is actually adding the directory tilde slash local slash bin. So my home directory slash local slash bin is now part of my path. And so whenever I enter a command and that program lives in here, the system will automatically find it. So if I hadn't done this, if I wanted to execute a program that lives in here, I would have to navigate to this directory or type this fully qualified path name, which could be really slow and really painful. So I actually want to do the shortcut to save me a bunch of time down the road. Okay, and so that's adding to your path. Is there any questions about that? I know it's kind of subtle if you don't always think about sort of command level stuff. But basically it's just telling the system, when I enter a command, I want you to search for it in this directory plus all the other stuff that was already there. Okay, so you can add that to your path if you would like. And so your bash resource file, we'd also have an extra line at the end that looks like that. So those are the two major modifications that I frequently make to my bash resource files, aliases and adding stuff to your path. You can do a bunch of other stuff. Basically, you can write any legal bash code, and it will execute whenever you pop up a new bash terminal. So these are sort of the standard ones that we use. Okay, so before we get into the scripts, which we'll spend the last half hour talking about the script, let's just talk very quickly about installing software. So that's something you may want to do. You may want to download software from the internet and install it on your computer. And there's a standard sort of installation procedure. So this may vary slightly between programs, but most developers that are writing code for Linux write it in such a way that you can always install it using the following recipe, which is basically download it. And so maybe you could use wget and download something from an STP site, or maybe you go to your GUI in your browser and actually download it and save it on your desktop. Either way is fine. You pull down the package. Usually it's compressed. If it's a tar tape archive, you'll need to decompress it using TAR. If it's a zip, you might use unzip. Then you will change directory into what you just unzipped. And so if it's app.tgz, what will come out of that is a directory called app. And so you'll cd into /app, and then you hit three things. The first thing you do is configure, and so you'll do /configure, and that runs the configuration script that came down with the program. If you want to install it in a particular location, you also provide this special flag. If you omit this flag, it just installs it in your default location, which is usually sort of your /local folder. You'll then type make, which will compile the software, and then type make install, which will install the software. And so if you want to practice using this stuff, if you look at that software installation guide that I hosted on Compass, which tells you how to install Quantum Espresso and LAMP on your personal computer, you'll actually follow this recipe to install Quantum Espresso and LAMP on your personal system. And so the recipe is the same. And so if you want to get some practice, that's a good way to learn. Okay, so like I said, don't memorize these things, just think of it as a library, but hopefully you have now an appreciation of all the sorts of different things that Bash can do, and now we want to sort of start putting them into practice. And so there are two things we're going to do. We're going to look through some scripts together, and then you're going to do a project. And so that will hopefully get you up to speed on Bash. Okay, so are there any questions so far about anything that we've covered today? No one's feeling too scared of the terminal. People are making friends with the terminal. It's becoming buddies. Okay, all right, that's good, very good. Okay, so now let's look at some scripts. And so these scripts are all hosted on Compass, so if you've not done so already, please go onto Compass and download these guys. They're also at this address, which is hidden, which hopefully you got at the beginning of class. So has everybody downloaded these scripts, or is in the process of doing so? Okay, so it's important you have access to these because number one, it's going to demonstrate some principles, and number two, it's going to provide you a lot of sort of sample code you're going to use in your project. And so let's run through them and sort of understand what they're doing. And so I encourage you to actually run these scripts as we're going through them, and you might also want to open them in a text editor on your GUI, or you may want to use VI or less or cat or head to look at these files also. Okay, so what is a script? So you hear about this thing bash scripting. You may have heard this, people say, I've been writing bash scripts. What does that mean? is nothing more than a list of bash commands in an executable text file. So these are human readable files. It's just a list of bash commands. In principle, you could open a bash script and actually just type all the commands into your terminal, and it would do exactly the same thing. It's just an efficient way of storing them. So it's like a little program, but we call it a script. Okay, and so it's a very powerful way to automate system tasks, sort of file downloads, system backup, submitting jobs, processing text files. These are all useful things to do in a script because it means you don't have to retype the commands every time. Okay, so don't be scared of it. It's nothing more than a text file. And so we can make this file using VI. And so you could do touch and then the file name to make the file. Then you could do VI to edit the file. You could also do it in Notepad or any other sort of text editor on your machine. And so use a lightweight text editor. Don't write scripts in Microsoft Word or any sort of fancy text editor. Why? Because those fancy programs add all these crazy extra characters that screw up your script. And so use the simplest method possible, which is either VI or Emacs if you like it better, or the Notepad utility on your system. And so just use a very simple text editor. If you start editing them in fancy software, I guarantee it's going to screw you up and things are going to break. Okay, so a script, like I said, is just a file with a list of bash commands, but you have to tell bash two things. You have to tell it that it's executable. You have to do change mode. So chmod 755, your script name, that makes it executable. And then you have to give it a little sort of signal at the very top of the file which tells it, okay, this is actually going to be a list of commands. So it's not just a text file, it's an executable file. And the way you do that is through the shebang line. And so it's called the shebang line because it's a sharp character followed by an exclamation point, followed by /bin/bash. And so what this line actually does is when you execute the file, it tells the system, okay, I want you to execute all the commands in this file using the bash shell. And so the bash shell lives in /bin/bash. So you execute the file, a bash shell gets launched, and then all these commands get executed. So that's a sort of classic, first mistake. My script doesn't run. What's the problem? Have you missed the shebang line? So make sure you always start it with the shebang. The other important thing is that when you write a script, you want to be able to look back on it later and figure out what it does. And so you want to add some comments to it. And so comments start with the hash sign. And so the sharp or hash or whatever you like to call this. And so you do sharp, and then whatever you write here is not going to be executed. It's just a comment. And so you can make it whatever you like. This is my bash script to do X. So I would encourage you strongly, if you're writing anything more than a trivial little script, to add comments to it, because you can look back in it in 3 months and not know what the heck is going on. Make sure you comment it for yourself and for any others that might use it. Okay, so let's write together our first script. And so this script actually came down from Compass. It's called Hello World. So you'll notice that I've been true to what I said earlier, not have any spaces in my file names because it sort of screws you up. And so this is what we're going to replicate. We're actually going to write it ourselves using VI. So these instructions show you how to write it. You can also write it in Notepad if you want. I think it's nice practice to do it in VI. So why don't we go ahead and do that together? Okay. Okay, so let's navigate to your home directory. And then let's make this file. So touch hello world. So I always like to do the touch to create the file first and then edit it with VI. Actually, you can skip this step and just start editing the file directly with VI. And if it doesn't exist, VI will automatically create it. So you can skip this step if you want. But I think it's useful because it makes the file first, and then the first thing I always do is change the mode. So maybe if you don't make the file first, you might forget to change the mode later. And so that's why I always make it first. And so let's change mode 755, which gives me read, write, execute, everyone else read, execute. And if you've not already found this trick, if you hit the tab character, you start typing a file name and you hit tab, it will autocomplete for you. So I can save you some typing. If there are more than one file with the same beginning part that you started typing, it will complain. And so you have to type a little bit further until it becomes a unique identifier. But that saves a bunch of time. Okay, so change mode hello world. So that file is now executable. Let's check that. So I'm going to do ls-al. Then I'm actually going to pipe it to grep and just pull out the line that says hello world. And so ls-al prints a bunch of junk. The one that I want is the line with hello world in it, so I'm going to use grep to do that for me. And so it just pulled out the line from ls-al that had hello world. And I can verify it's read, write, execute to me, read, execute to everyone else. Okay, so let's open the file with VI. So VI hello world. And then you get your VI editor. So is everyone with us? Stick your hand up if you're having problems. Okay. All right, how's it looking?
So what's that? Okay, again?
So space, and then grep.
G-R-E-P?
G-R-E-P. Space, and then hello world.
So what does this do?
So what you're doing here is you're doing LSAL, which printed out all that stuff. And then you're piping that output directly to the grep command. And we remember that grep does this keyword search for us.
Oh, okay.
And so it's going to search and pull out only the lines that have hello world in it. So very efficiently, you've zeroed in on only the line in ls-al that had your hello world program.
Oh, okay.
And so you can now look at the privileges that are associated with that. So,
okay.
so it looks good. Okay. Okay, so then let's make our script. And so we start in the nav mode, so we're going to hit lowercase I to enter the insert mode. And then the first thing we start with is the shebang line. So sharp bang, make it a little bit bigger, /bin/bash. Okay, looks pretty good. So then let's hit enter to go down a line, enter again to go down another line, and then let's add a comment. So to remind me, this is my hello world script. Looks pretty good. Let's hit enter twice more to go down 2 more lines. And then let's actually put the executable code in. And so all we want to do is have the program echo to the screen hello world. So the simplest possible program. And then we're going to hit escape to get back into nav mode. And then we want to save the file with :W. So now we've written our script. Is everyone okay with that? Everyone's written their first script using VI. Anyone having problems? Don't be afraid. Stick your hand up if it's not clear. Okay, looks good. Let's see if we've done our job. So we're going to hit :Q to quit out. And then we're going to see if we can execute it. So we remember that the way you execute a script or any other executable file is to provide bash with the path name to that particular file. So we can do a couple of things. We could write down the entire path, so you could find out your PWD, and so you could execute the script doing users/al/hello world, and that will execute the script. Or if you happen to be in the directory where hello world lives, so you hit ls, hello world is living right here, you don't have to type the whole path name. You can do current directory/hello world. And so it's like a shortcut. And this is a common way of executing a program. Rather than typing the whole path name, you navigate to where the program lives and then just type /program name. Okay, so it seems to be doing its job, and so it's spitting out hello world. So is everyone getting hello world printing to the screen? All right, congratulations. You've written your first bash script. So you're all now proficient bashers. Okay, so let's look at things a little bit more complicated. So much for hello world. So very good. You feel very proud of yourself having written your first bash script. So now we're going to look at a bunch of other scripts. And so if you want to execute them as I'm talking, as we're going along, that's great. I also recommend you look at them. So use probably less or cat. The reason I don't want you to use VI is because then it's very easy to actually edit the file and make a mistake. Less and cat just allow you to view it. And so you're not going to be allowed to even make any edits. So then once you get comfortable with what the scripts actually do, then you can start playing around with VI and maybe modifying them for your own ends. If you do happen to screw up the script, don't worry, you can just re-download it from Compass, since it's going to be there for you. Okay, so in the next few slides, what I'm going to do is show you a bunch of scripts. I think we have 7 or 8. The bullet point is going to be the concept I'm trying to illustrate with the script. I'm going to show you the script with some comments telling you what each line is doing, and then show you the execution of the script in a bash terminal that I've just taken a screenshot of. And so the idea here is this is meant to be showing you particular concepts, explaining the concepts, and then showing how you actually execute them. So then when you execute it yourself in your bash terminal, you should see something that looks very similar to this. Okay, so passing variables. So this is an important concept. And so let's look at the script. It's called backup. We start with the shebang line. The comment tells us we're going to compress and store the current directory. And so what we're going to do is make a tape archive of whatever's living in the current directory. And then we're going to call this tape archive bkp.tgz. And so this is taking /wildcard character, everything that lives in the current directory, and it's dumping it into a tape archive called bkp.tgz. Then we're going to move that tape archive. We're going to do move backup bkp.tgz to bkp_$1.tgz. So what the heck is that $1? So $1 is bash script shorthand for the first parameter you pass to the bash script, meaning it's the first parameter you type after the execution of your script. So let's see how that looks in practice. So I'm going to my present working directory. I can see that I have backup living in here. And so I'm going to type the name of the script, making sure it's executable. And so you might have to do a change mode 755 to make the script executable. And I'm going to call the script /backup. So that's making the script run. And I'm going to pass a parameter 29th of July, 2013. So for instance, you might replace that with today's date. And so what's going to happen is it's going to back up all the files in your current directory to bkp.tgz. And then it's going to rename bkp.tgz bkp_29th of July 2013. And so you have a snapshot of all your files in your current directory at a particular date. So then you can hit ls, and you can see whether that file really exists. So is everyone okay with that? Folks have got it to run. Any people have any questions about passing parameters? So it's very extensible from there. So $1 is the first parameter you pass. $2 could be the second one. $3 is the third one. So you can make as many parameters as you want. I guess more formally they're called arguments. So it's the arguments to your bash script. Okay, so a backup. So this is a nice way of writing a sort of very general script that doesn't have parameters hard-coded into it. We can actually pass parameters via bash arguments. And so this is very general because you can just change the date and make snapshots according to different dates. Okay, so let's keep going. So if you have questions, please do stop me. So I hope I don't go too fast for folks. But let's go to the next one, which is summer. And so we're going to do some summations. And so what I'm illustrating here is the while loop, these special calls, $sharp and shift, and some arithmetic comparisons. Okay, so let's look at summer. And so if you pop this in less or cat, we've got the shebang line at the top. The comment line says we're going to sum all the numbers that are passed to the script. And so you pass a bunch of numbers as arguments to the script, and this script is, or so it claims, is going to sum them all together. So let's see how it actually does that. So we're going to illustrate, first of all, a while loop. And so we initialize our sum to 0, and so we assign the value 0 to this variable sum, and then we start a while loop. And so if you've done any sort of programming before, you know that while loops are a very common idiom in programming. And so what we're going to do is while $sharp is greater than 0. And so what the heck is $sharp? So $sharp is the number of arguments that you passed to the bash call. So it says, while the number of arguments I've passed to the bash call is greater than 0, I want you to do something. And so this may sound a little strange, but we'll see why this actually works. So just bear with me. So we're going to semicolon do. We're going to echo the new number, which is $1, which is the first parameter. Then we're going to do sum. We're going to use the expr tool to add the current value of sum, so $sum. This dereferences sum, so the current value plus the value of the first parameter. And then we're going to echo the current value of sum to the screen, echo a new line, and then we're going to call this shift. And so shift is an important call because what it does is it basically throws out the first argument and moves the rest down. And so imagine we call /summer 3, 4, 5. And so when you first enter the script, $1 corresponds to 3, $2 corresponds to 4, and $3 corresponds to 5. As soon as you hit shift, what this does is it throws out the top parameter and bumps everyone else down 1. So 2 becomes 1, and 3 becomes 2. So it's a very efficient way of sort of running through your parameter list. And so what this means is that this $sharp starts to decrement. And so we start with 3, it goes down to 2, it goes down to 1. As soon as you hit 0, then the while loop exits because it's run out of parameters. And so every time we can just call $1, because it's like calling the first parameter that still remains in the argument list because we're making use of the shift command. So shift just sort of bumps all your parameters down 1 until there's none left. So any questions about that? I know that's sort of a little bit subtle, but this is a very powerful idiom, which is why I wanted to show this to you. So it's much more powerful than just writing $sum plus $1, $sum plus $2, $sum plus $3, because then that would be restricted to only 3 arguments. This is completely generalizable to any number of arguments. So very nice, powerful concept. Arithmetic comparisons, -LT in this while loop here. So you open square brackets, you have one value, you have a comparison, you have another value, then you close the square brackets. So in this case, we have greater than. You can also have -LT, which is less than, -LE, which is less than or equal to, -GE, which is greater than or equal to, -EQ, which is equal to, and -NE, which is not equal to. So all the usual suspects. And so you can have whatever one is appropriate for what you're trying to achieve. So again, don't memorize this. This is a library for you to look at. If you ever need to write a while loop, you can come and look at this, see how it looks, and adapt it to your own purposes. Yeah? Which is the new num? Right, okay, so what we're echoing whatever's in here to the screen. And so what we're going to echo to the screen is actually the word new num equals, and then we're going to echo the value of this $1. If we had enclosed this in single quotes, what would have been echoed to the screen? It would have actually just printed exactly this. We would have said new num equals $1. Because we're using double quotes, Bash is smart enough to say, okay, I know what you mean is actually the value of your first argument, the value of $1, rather than $1 in text. So if you want, you could modify that and see what happens. But yes, that's not a variable because it's enclosed in the double quotes that we're passing to echo. So it's just saying, hey, echo, I want you to write to the screen whatever's between these double quotes. Good question. Yeah. So $sharp is the number of arguments in your bash call. So if you write /summer 10 - 4 9 17, $sharp starts life as 4 because there are 4 arguments here. Do you agree with that?
Yes.
Okay. So then as you progress through the while loop, every time you hit shift, it throws out the first argument and bumps the rest down. And so the first time you call shift, it throws out the 10, and then you're left with 3. And so $sharp becomes 3, then $sharp becomes...
without the shifting, this thing is not stopping.
Exactly, that's right. So the shift is vital. Yeah. Exactly, that's right. Good point. Okay, so much for summer. So let's go to Oracle. So Oracle is a script trying to illustrate the if-else statement and also some nesting of loops. Okay, so let's open up Oracle in less. You get the shebang line. It says it's an Oracle guessing game. So this is a game with which you can amaze your friends. The first thing we're going to do is assign the value 15 to this variable magic number. Okay, so magic number has the value 15. Then we're going to hit an if loop. So again, if loops, very common, very important programming idiom. And so if, we're going to open the square brackets, $1, which is the first argument passed to our bash script, is equal to the value of the magic number, then we're going to print to the screen, you're correct. Sounds good? If that's not the case, else, so if $1 is not equal to the magic number, we enter this block of code. And so then we're going to nest another if loop. So there's an if loop inside an if loop. So it's completely legal. It's a very important thing to be able to do is nest loops. Okay, so we didn't guess the right number, so what's going to happen? If $1 is greater than the magic number, then bash is going to echo to the screen, you get too high. Otherwise, meaning it's less than the magic number, it's going to echo to the screen too low. Okay, so it's a pretty simple game. We're just trying to guess the number, and the script is going to give us some feedback as to whether our guess was too high or too low. So important things to note here, the if clause looks like if, open square brackets, some comparison, close square brackets, semicolon, then. Then you have an else, and you have an fi to close the if loop. So let's go back one slide just for a second. So while, it goes while, do, done. When you have an if loop, it goes if, then, phi, which is just if backwards. That's going to be clever. Okay, so this is an if loop. And so you can execute the script, and you can get some numbers and see how well you do. And then obviously you could modify this number using VI and then change this from 15 to something else. So just a little bit more advanced, you can always nest if loops, but you can actually also have else if statements. You can do if this, then do this, else if this, then do this, else if this, then do this, if none of the above, then do this. So that can also be useful. So the first if statement that rings true, the first time the square brackets is satisfied, that thing gets executed and the loop terminates. So say you hit this guy, then this executes and the loop terminates. If it's not true until this guy, then this executes, then the loop terminates. And so this can be a useful way of doing things, not just if else, but if, else if, for how many you want, then anything else comes in the else. Is that clear? If you don't understand that, don't worry about it. You can do everything you need, just nesting loops. Okay, so calculator. And so what is this trying to illustrate? The script is trying to illustrate the case conditional, the exit call, and some defensive programming. So let's open up calculator. So if you type less calculator, shebang line, comment line says this is a calculator for integer pairs. Okay, so it suggests that we can do some arithmetic with integer pairs. Very good. And then this is the defensive programming concept. And so we're trying to safeguard the usage of this code. So if $sharp is not equal to 3, then we have an unexpected number of parameters. And then it tells us to echo to the screen, okay, you called this wrongly. How you should call it is ./calculator, your first integer, your second integer, and then your operation. And so at a minimum, if you don't have 3 arguments, this script is going to fail. And so we're not doing any checking on the character of the arguments. All we're doing is checking that, at least you have 3. Because if you don't have 3, it's definitely going to break. So you could be a little more defensive by adding some extra stuff. Check that the first argument is an integer, check the second argument is an integer, check the third argument is an operator. But let's just do some basic checking right here. And so if this number of arguments is not equal to 3, it echoes us some output to the screen, and then it exits. And so basically just exits out of the script. And so the script says, I caught an error, I'm going to exit. And so anytime you exit, you probably want to write to the screen why it exited. So the user has some idea of, what the problem was at least. So if you make it through this block, meaning that $sharp is equal to 3, what the heck is going to happen? So we're going to enter this other block, and so this is this so-called case conditional. Again, it's another important programming idiom. And so basically it's going to do a bunch of tests on our third argument, and it's going to execute a particular line of code depending on what that argument is. So I think we probably could have done the same thing using if, else clauses, but we're going to use the case conditional because it's actually more compact when you have more than 2 choices. And so let's go into this. And so it says case, then the argument, $3, you got to enclose it in quotes, that's just the way the syntax works, in, and then you have a bunch of blocks that says if $3 is within the arguments that are placed here, execute what comes underneath. So let's run through that. Okay, so the case conditional opens with case, and it ends in ESAC, which is case backwards. This one curly bracket terminates the pattern match. This double colon terminates each case. The pipe character is actually the OR indication, and the dollar is the catch-all. And so that's just the syntax. The best way to understand it is just to look at the example. So let's run through. So our case conditional is operating on our third parameter, our third argument. If this argument exists within this list, i.e. either it takes on the value add or takes on the value sum, close the list, Then what I want the script to do is do z equals expr $1 plus $2. So we want to add the first two arguments. Then we're closing out this case. So we're done with that case. Next case. If it passes through here and $3 is actually equal to subtract, I want you to do $1 minus $2. Close the case. Next case. Multiply. Do the multiplication. Divide. Do the division. Anything else. So you've made it all the way through here and you still haven't hit a case. So this is the wild card. This means anything else. So then I want you to echo to the screen 4 supported operations. Add, subtract, multiply, divide. You didn't hit any of them. So let's exit out. So then the code is going to exit. Then we're going to make it through the case conditional. Provided we didn't exit out at this point, we're going to echo to the screen $z, which was the value that we actually calculated. And so let's look at this in action. So this is where my script resides. I'm going to try and execute the script. The script gets angry. It says, error, unexpected number of parameters. This is the way you use it. And then the script exited out. Okay, I understand how to use it now. Let's do calculator 7, 3, add, 10. Very good. 7, 3, sum, 10. Did the same thing because in our case conditional we said you can either use add or sum. Both of them are valid. Subtract, 4, multiply, 21, divide, 2. So seemed to work out pretty well. You might want to play with divide. If you can see here that 7 divided by 3 apparently equals 2. So why is this true? Well, because it only does integer arithmetic. If you want to do floating point, we have to do something different. So this is integer arithmetic. So any questions about the case conditional? Yeah.
So if you write, let's say, sum 7, 3 with a redirection.
If your arguments were sum 7, 3.
Yeah, as opposed to 7, 3 sum with a redirection.
So what's your guess?
No.
Right. So why do you say no?
Computer's that smart.
So you could make your program that smart. It would be painful. But let's see why. Because the case conditional is operating on $3. And so if you have your operator in $1, it's not going to work.
Oh.
If you had sum 7, 3, you'd be testing whether the value 3 matches any of these operators, which is not true. So you could try it. If you type it in, what will happen is that you'll pass through all the way to here, and you will echo 4 supported operations, this, and this, and your 3 didn't satisfy any of them. So yeah, give it a go. I mean, it's not going to hurt anything. You can try it. Any other questions? Okay, so I don't want you to obviously be able to sort of reproduce these scripts immediately. What I'm asking you to do is sort of understand them and maybe be able to adapt them to your own purposes. And then once you get comfortable with it, sort of recognize the idioms, you can start using them for your own ends. So again, think of these scripts as a nice library you can pull on. Okay, so maybe. Yeah, we can maybe do this one and then we'll quit. And so stringer. And so let's quickly look at this script. Shebang line. This apparently appends .txt to all the strings that you pass to it other than the string virus. So that could be anything. So what we're trying to illustrate here. So first of all, $@ is shorthand for all the arguments that you passed. So remember $# was the number that you passed. $@ is actually the parameters themselves. So the list of parameters. So what we're going to do then is store that in an array. And so string array equals, open the brackets to make the string array. You need double quotes to enclose it, all the arguments that you passed to your call. And so it's going to dump all the things you passed to your call into the string array. You can then echo the contents of the string array using this special idiom, which is $open curly brackets, the name of your array, then square brackets @. So this is very tortured syntax, and I never remember it, so I always have to look it up every time I use it. So that's sort of the purpose of this slide, that you can look it up. And so this is going to echo to the screen what you've stored in string array, which is all the arguments that you've passed to your bash call. Okay, then what we're going to do now, we're going to create a new array that's going to be empty. And so this is open bracket, close bracket. So this is an empty array called file array. Then what we're going to do is a for loop. So for every string, str, that lives in the string array, do the following. Check if the string you pulled out is not equal to virus, because we don't want to deal with a virus. Then what we're going to do is, so this is the array size. And so we're going to do the size of the file array. And then we're going to do file array do some arithmetic, and so the expression, the size plus 1, is equal to the string.txt. So what's actually happening here? We're saying, provided the string we're passing in is not equal to virus, so one of the arguments we passed is not equal to virus, we're going to say, okay, how big is my file array? So this is going to start like 0 size, and then we're going to add an element to the file array, which is element number current size plus 1. So the first one is going to be added the element number 1. And what's the value of that element going to be? It's going to be the string.txt. And so this empty double quotes make sure that we make a break between string and txt. Otherwise, bash might try and dereference the whole thing, str.txt, when in fact we just want it to dereference the string part. This tells it there's a break here, and add.txt to the end. Okay, then we end the if loop, and we're done with the for loop, and then we echo the contents of our file array. So a little bit more complex script, so I recommend you're probably going to have to take a look at this and run it a couple times, see what's actually happening. Just get comfortable with it. But basically what's happening, let's call it stringer good, bad, ugly. String array is good, bad, ugly, so we've taken our arguments, we've dumped them in string array. File array at the end of the day is good.txt, bad.txt, and ugly.txt. So it's just appended .txt to all the arguments we called the script with. If we make another call with clean1, virus, clean2, and clean3, the string array contains clean1, virus, clean2, clean3, but the file array only contains clean1.txt, clean2.txt, and clean3.txt. So it omits to do anything with virus, which is the behavior that we wanted. So a silly little script, but it's actually pretty complicated. And so get comfortable with this idea of making arrays, sizing arrays, incrementing things using EXPR to access different elements of the arrays. So I recommend you just take a little bit of a look at this. And then the string comparison is just a library of them there. And so we've done a not equal string comparison here, but you can also have equal, greater than, less than, not empty, empty. So again, just a reference for you there. Okay, so let's call it there today. And so we'll finish up Bash next time. If you're already a Bash expert, the Bash homework is already posted on Compass, so you're welcome to start working on that right now. You probably have most of the things you need, but we'll finish up on Tuesday. But if you want to look ahead in the slides, everything's posted. Okay, sounds great. So see you next week. Thanks, folks. Both are. So the quiz and the project. So they're both due on September 11th. And so the quiz is an online Compass quiz. The project, you have to do the project and make a PDF and submit it via Compass. Okay. So if you go to this web address, I posted everything up there for folks that don't have access. You can download it. So did you register for the class? Yeah. Okay, so Compass will pick that up in a couple days. Okay.